So I will explain the work that we have done for a few years now about flywheel energy storage, hybrid generating sets, and our goal is to provide really renewable energy. So first of all, François told that maybe to you, we have 3 weeks ago been the winner of a global innovation contest in Paris. So that was organized by the Prime Minister in France and the Minister of Finance and Anne Lauvergeon, who was the former director of the nuclear French energy, which is very powerful. And we were the winner for the category energy storage with a project of solar flywheel that I will explain to you.
Bravo!
Thank you. So that was the ceremony. This is the French Prime Minister. This is the Minister of Economy. This is me. Okay, the product that we intend to produce is what we call a solar flywheel. So, in fact, to make it simple, it's an energy storage, but it's a renewable energy storage that is able to store all the solar and wind energy that are intermittent. Of course, it is connected to an energy management system. You can add a generator if you want a backup, or you can use our hybrid generator, and it can be also connected to the grid, but it can be grid independent. So it's as you want. The only goal of this system is that the customer has always renewable energy to provide his energy needs. Our innovation is in an ultra low-cost energy storage. Energy storage is possible, but at a high cost. So we do not need to innovate in better, higher performance energy storage. We need to reduce the cost of energy storage. So this is the goal of our work for the last few years. So basically, to explain how it works and how it is made, it's a steel disc that is turning at high speed. High speed for us is a few thousand RPM, so it's not ultra high speed. It's the same speed that you can have in your engine, for example, in your car. It's in a vacuum casing, because if you have a steel disc turning at this speed in air, you will lose the energy rapidly in about 1 hour. So we make the vacuum in the casing with a vacuum pump. It's easy. You have also a vacuum pump in many cars. It's not expensive. We are turning on ball bearings. So this is not rocket science. This is something which is very reliable. But there was a problem because lubrication of ball bearings in a vacuum is difficult. So this is why we had to work hard in order to make it work for a very long time, and we could have patents for that, these innovations. And the last thing is, how do you get the energy in and out of the flywheel? You just use what we call a motor alternator. In fact, it's a special machine that can push the energy inside the flywheel by spinning it at increasingly speeds. And when you reach the maximum speed, then you reverse it in an alternator to get the energy back from the flywheel. From the user point of view, you just have 2 connections to get the energy like an ordinary battery. So it is called kinetic energy. That's the energy of speed. So why is it so low cost? In fact, we call it the perpetual battery because it is designed for a very, very long operation time, several decades. Of course, we use only common low-cost materials. It's made only with steel and copper. You have some startups that are making flywheel, high-tech flywheel with carbon fibers. It's high-tech, but it's aerospace technology. It's very expensive, so there is no chance that you get one in your home. It's too expensive. Steel is 10 times cheaper than carbon fiber. So this is our choice to make something that can go to mass production. Of course, we have all the manufacturing available. You don't need to invent some new kind of manufacturing system because it's only iron forging, it's copper coiling, and so on. So we have already suppliers that can provide us the parts at low cost without investing in new technologies. And the most important is that we have a provable infinite life. We have worked with our supplier of ball bearings, of steel, and we can prove that there is no wear in ball bearings. So that's surprising, but that's reality. No need to change them, and no fatigue in the steel. This is a property of mechanical systems. You can design for perpetual system provided there is no wear. So if we compare the cost of batteries with flywheel, what do we see? That the initial cost of lead batteries, that are the lower cost batteries, is maybe very low, but the lifetime is very short. So if you look at the cost of storage, which is what is very most important, you have a cost of storage of nearly $0.4, and this is expensive because the cost to produce energy is about $0.1. So storing energy in a battery costs 4 times the cost of producing energy. This is why usually you don't store energy in batteries in large quantities. You have a lithium battery. Of course, it's much better in terms of weight. This is why you have it in your laptop and mobile phone. But it's extremely expensive, and it has a very high cost of storage. It's higher than lead battery. You can see the figures on that chart. The steel flywheel right now at the beginning is already at the same cost as lithium battery, about $1,000 to store 1 kilowatt hour. But the big difference is that we have unlimited lifetime. So if you compute the cost of storage, you need to know the application. If we are in a solar, for example, storage, we will make 10,000 cycles in 30 years. So we get a cost of $0.1. So already at the beginning, we are 4 times less expensive than lead batteries. And if we put this storage in an hybrid genset, we can make more than 100,000 cycles every 30 years, and then the cost of storage is nearly 0. So we have something which is very, very interesting to replace batteries. Everywhere you have a massive pack of batteries. And our technology is emerging. It means that with mass production in the future, we think that we can provide a flywheel with a cost of only $200 per kilowatts. That is the same cost as batteries. And in that case, we have a tremendous market. So you have seen the hybrid generator, though I don't need to spend a lot of time to explain it. You have the engine that can work with gas or diesel or any kind of fuel. You have a mechanical transmission, flywheel, alternator, and electronic inverter. I don't want to spend too much time on technology. Just to explain you how it works, it's intermittent operation. So the engine charges the flywheel at maximum power, and when an engine is at maximum power, it has the lowest fuel consumption, lowest pollution, everything is good. So it's much better than partial power. then the engine remains stopped most of the time. In our application, we have tested it on an office, a home. It's stopped more than 90% of the time. So you get savings on the fuel, the service, because if the engine is turning only 10% of the time, then the service is 10 times longer, excuse me. And also the lifetime. If you have an engine turning 24 hours, the lifetime usually is about 1 year. It's very short. But if the engine is turning 10% of the time, then the lifetime can go to 10 years. And our objective is to design for 20 to 30 years. So this is the fuel consumption of our technology compared to a classical genset turning 24 hours. So what you can see is that we are better in every power, but especially at low power. And remember, low power is where you get the most of the time in many applications. It's very, you are not very often at maximum power. So 1.5 kilowatts is the power needed by a mobile phone relay. We have worked with Orange in France, and we get a 60% reduction in the fuel consumption. 500 watts is the fuel consumption of a typical home in France. We divide the consumption by 4. And at zero power, at idle, you get the power, that is, you have all your systems that are energized, but the consumption is divided by 10 compared to a genset that works for nothing. So that's dramatic figures. Something also that is very important for us is that it can be really renewable. The machine that you have seen is working with 100% pure plant oil. It took us a few years to be sure that it works, and we had the approval from the French government. In France, it's forbidden to put oil in an engine unless you get approved after several years of testing. I don't want to explain all about biofuels, but what you should know is that ethanol, plant oil, biodiesel are called the first generation, but now are coming second and third generation biofuels. So in the future, we will have a lot of renewable fuels. Something which is important, not easy to understand, is that our technology can provide renewable energy at any time, not just on the mean. In France, we have many houses, many buildings that are net zero. In fact, they say our building consumes less energy on the grid, or zero energy on the grid, but on the mean. It means that they put solar panels on the roof, and they say the solar production is the same as the building consumption. But this is on the mean only, because in summer you have too much solar energy and you need to put it in the grid, and in winter you have not enough solar energy and you need the grid, and of course it's coal, it's nuclear, it's gas, so it's polluting. So it's not really renewable. So one of our market targets is the really zero emission buildings. Something that we cannot demonstrate here is what we call cogeneration. When you produce power, you get usually low efficiency, 50% maximum. So a lot of heat is lost in the nature when you have central generation. If you make local generation inside the building, then this heat can be recovered very easily. You can get efficiency like 90, 100%. So our technology is very perfect for the low energy buildings. In fact, buildings that are very, very well insulated, because they need nearly no heat. So you put the machine, you get all the power, the heat is good for the hot water needs, and that's it. But of course you have all the old buildings that need a lot of heat. And this is a problem because insulation is very expensive. So we have a solution. If you connect the hybrid genset, our genset, with a heat pump, then you get, as you can see, 1/3 of the energy as electricity. The heat pump has a coefficient of performance of 4, so you get 4/3 of energy. It's not energy creation, it's taken from the environment, the outside air or the ground. You have cogeneration, you get that, so the net result is that you get 200% efficiency. What it means in, I would say, simple words, your gas bill is cut in half. So this is something which is very interesting for all the buildings that are hard to insulate. And of course, in the future, when we are in mass production, the heat pump will be just integrated inside, and we have everything in the box. So we have made a test on many sites. The first one was a house in a small village in France, near the river, and that enabled us to test the soundproofing, because of course it shouldn't be a problem with the neighbors. The second one was a BTS, that is a mobile phone relay belonging to Orange, the French telecom company. And they had a problem because they had not the grid there. It will take several months to obtain the grid. And they had not the permission to put a conventional genset because of noise and pollution. So they took our genset for several months until the grid comes. Another example on the high-speed train line, this relay was not connected to the grid, so when people were traveling, they had an interruption in their phone conversation. So it was urgent for Orange to get some power, and we powered that relay for, I think, nearly 1 year before the grid comes. And also our factory is disconnected from the grid since 2009. So 5 years of renewable energy. Here you can see the machine during testing, and you can see that we get the hot air from the machine for the HVAC system, just to heat our factory. So the markets that we are looking for, I mentioned the telecom market. Here it's not a big market, I mean in industrialized country, but the main market is in developing countries where there is no grid. Housing, off-grid housing, and rural electrification. So now we are working with, how do you call that, NGOs that are putting power in Africa. One of their main concern is that in Africa, half of the agriculture production is lost because they have no conservation means. They have fridges, but they have no power, no reliable power for the bridges. So they lose, on the mean, nearly 50% of their production. Backup power, of course. UPS, uninterrupted power supply. In fact, we combine both of them because our genset can be, of course, backup power, but because of flywheel, we have a battery that is always on and never fades. So it's very reliable. Zero emission buildings, because if you have solar panels, we can store the solar energy. Maybe you recognize this building. So François is very interested. PV solar plants. So this is new, but now PV solar plants will need to have storage, because if you make too much solar energy, it comes once at a time, and the grid cannot absorb all that energy. It becomes very difficult, for example, in Germany, where they have a lot of solar. So now next solar plants will have storage. And our final building is that, our final goal is to equip all buildings. Instead of the grid, instead of the air conditioner and the furnace, we combine everything in one machine that can be fueled by natural gas or renewable fuel. So investors, they always ask, what is the market size? So we have sized some markets. One is telecom off-grid power. In developing countries, the association of GSM says that there are nearly 1 million off-grid mobile network sites. And so it's a tremendous market, because currently you have usually classical genset turning 24 hours. So there is a tremendous pollution also. Backup power market, it's easy to have the size, because Generac in America has 70%, and we know the turnover, so it's a 2 billion per year market. Solar power plant, the first solar power plant in US with storage was built end of last year, and it cost $2 billion for only 280 megawatts. So it's very expensive, and we have a better solution for energy storage. Just one business case, very quickly. It's the off-grid telecom business case. So Orange told us to make the comparison between the classical genset, battery hybrid, so it's the same as what we are doing but with a battery, solar solution, and our Energiestro hybrid solution. What you can see is that the classical genset has a low cost, but because it's not reliable, they need two. So this is the cost of two classical gensets. This is the hybrid with battery, so you have very large initial cost because of the battery. If you add solar panels, it's even higher. So what is interesting is that we have the same initial cost as the classical genset solution. But of course, after, the classical genset will consume a lot of fuel, will consume a lot of service, because you have to service it every 3 weeks, and you have to change the genset every year. So the cost is very, very high. And we have 20-year lifetime, so very small consumption. So basically, if you compute the cost of energy, we divide it by something like 3, I think. Just to present myself and the team. So I am an engineer from 2 schools in France. Arts and Métiers is equivalent of MIT, and Polytechnique X is equivalent to West Point, for example, American examples. I spent 15 years in the Total Energy Group, maybe you know this company, and there I had 25 patents that are in operation in the automotive industry. And my wife is the president. We have an engineer, we have someone for communication who made the video, the website, and so on. And we have at the board people who are from the energy domain, Miguel Caparros, and a former self-made man, Gilles Moret, who made his own company in electronics. I come to the end with our proposal. So our idea here is to create a new company for United States. which will have the exclusive license of the technology for United States or even the whole Americas. It will design, manufacture, and sell solar flywheels and hybrid generators. It will be self-sufficient. Of course, we hope to locate it in Kalamazoo. And I will be the Chief Technology Officer. All the other directors will be American. I will not come through all the figures. There are too many. It's just to show you the size of this venture. We think we need approximately $5 million to begin series production within a year. And we can get revenues of more than $100 million within 5 years. I hope we will be able to do that. That would be fantastic. So if you are interested in such a venture, you just contact me or François. We are here. I am here for that. François told me, don't take a return ticket. You will have to stay in America. So, thank you.